Hi, I'm Randall Heyman, a university mathematics academic. I'm using my YouTube channel to help university educators, teachers, students, and parents with mathematical problems and concepts that they're having difficulty with. So if you're impacted by the coronavirus and would like me to make a video for you or your students, please use the comment section below the video. So we're up to rings part 3, and finally we've got to answering one of the 3 specific questions that a teacher in California asked me, polynomial rings. So let R be a ring. I'll give an example, a couple of examples soon. So R is a ring. So think here just the integers. We call this R with the square brackets X a polynomial ring if Rx it's the set of all polynomials that we're used to. So expressions of the form a0 plus a1x plus up to am x to the m. And here, every ai has to be an element of the ring. Remember, we said back here that R is a ring. So we said back here, R is a ring. So every element of that has to be a ring. And the m, this m here, has to be a positive integer, could be 0 as well. So I just warn you, sometimes you'll see this defined slightly differently. They'll define this, this going off to infinity, but then they'll say that there's only a finite number of AIs that are not equal to 0. So they sort of contemplate a situation where it goes off to infinity, but once you get to a certain point beyond that, it's all 0. So it's basically the same as I've got here. We have normal addition and multiplication. So let's just go with an example. So the classic one is this one, Zx. So an example of an element would be, say, fx equals 1 plus 2x plus x squared. That would be fine because 1 and 2 are elements of, so I suppose what we could put here is, I suppose we could put since. I suppose something like gx equals 1/2 plus pi x, that is not an element of that ring because the coefficients are not integers. Let's put up another one, hx equals 2 plus 3x. And now we can define, when I said normal addition, it's just what you normally expect, fx plus hx. We'll just add it up. So we'll add the constants, 3 plus 5x plus x squared. And what about fx times hx? Well, we'll just do that in the way that we would normally do it. If you look up some books, they'll give you the formula that shows you with summations, which tell you how to work this out. But I mean, we basically know how to work this out. So what's that? 2. We've got 4x plus 3x. I suppose that's 7x. We've got 2x squared plus 6x squared, 2x squared plus 6x squared. I suppose it's 8x squared. And then we've got 3x cubed. So that's your garden vanilla polynomial ring, or ring of polynomials, it's often called. Let's do another example. Because I mean, anything we talked about last time as a ring, we could use here. So I'll use, let's use Z. I'm going to use Z3 X. And here, Z3 is what we talked about before, sort of a plus b root 3, where a and b are rationals. So we're going to, so examples of, so we could here have fx could be equal to 5 plus 6 root 3 plus 2 minus root 3 times x plus 100 root 3 x squared, and we could have an hx is equal to 7 plus 3 on 2 times root 3. Remember, we said that they can be rationals, plus 17 on 35 x minus root 3 on 2 x squared. And if we wanted to, we could just multiply them and add them in the way that we normally do. So that's the ring of polynomials. And I'm not going to go in, unless someone asks me specifically, I'm not going to go into what I just write up here. I'll just mention it in closing. And that is, you can have multivariate, you could have a polynomial, a ring of multivariate polynomials. So here, example, I'm thinking of something like Z. Rather than just having X, we might have X and Y. And so this would be, so an example here of an element might be fx equals 5 plus x plus 10y plus 11xy plus 15y cubed, something like that. So this is multivariate polynomials. Okay, any more questions on polynomial rings, please comment below. Otherwise, so I've sort of done this one. I think we will probably now head towards zero divisors, and then we'll look at quotient fields. But if you've got any questions on anything to do with mathematics, please comment below and I'll see if I can help you out.